All right, guys, today we're going to start looking at tangent lines in more specificity. So previously we've looked at derivatives and how derivatives really are the slope of a tangent line, right? So if I have some sort of curve function like I have here, and then I draw a tangent line at a certain point, oops, then the slope of that line is the instantaneous rate of change of that curve. So when that curve is changing at this very instant, we can actually calculate that rate of change, and that's our derivative. It's the slope of that tangent line. So what we're going to be doing now is we're going to be using that to find equations of a tangent line. So not only are you going to find the slope, but you're going to find the equation for the whole tangent line as well. And this kind of works through the whole process. So I'm just going to kind of be talking through it and then adding notes as I go for ways for you to remember things and to know things. And so it shouldn't be too terribly bad. Okay, so typically the recall information, recall information is a tangent line is a line that locally touches a curve at one and only point, right? So just like what we have right here. And then a tangent line, slope-intercept form for a line is y equals mx plus b, where m is the slope of the line and b is the y-intercept. This is useful if you know your slope, so m, and you know b, your y-intercept. So this is when you would use that equation, right? When you know m and b. The point slope formula for a line is when you have y minus y1 equals m times x minus m1. And this formula is more useful for calculus because it doesn't require us to know the y-intercept. It just requires us to know the slope and then a point on your line. And so when we're finding the equation of the tangent line, what we're basically going to be doing is we're going to be figuring it out at a particular point, and then we'll be calculating the slope of that line at that point. And so for the most part, your equations of your tangent lines are going to be in this form. So this is something you have to know. Some other stuff you have to be able to know in order to do the equation of the tangent line is you have to know that the first derivative is the slope of the tangent line. And then there's a couple of different ways that we can find the first derivative. So obviously there's the definition of the first derivative, as well as all these rules that we've just learned. So power rule, product rule, quotient rule, and chain rule. Okay. With those formulas and definitions in mind, we can find the equation of our tangent line. So let's consider a pretty basic tangent line problem. So find the equation of the line tangent to the graph f of x equals x squared at x equals 2. And so having a graph in this scenario is helpful, but you're going to develop a method so you don't always have to have a graph. So basically we're finding here is our point, and the tangent line that goes through that, we're going to find the equation for it. And so to do that, we're going to need a couple of things, right? So I said that we would need the point that's right there, and then we would need the slope of that line in order to find the equation of the tangent line. So in this example, they go ahead and they're like, well, hey, look, we're going to find slope first, right? The equation for the slope of the tangent line is your derivative, so that's your m, basically. And so we do our power rule, we get f of x equals x squared, so f prime is 2x, right? Take the derivative. And then therefore, at x equals 2, the slope of the tangent line is f prime of 2, which is 4. So basically, this is my slope, m equals 4, okay? So now we know the slope of the tangent line, which is 4, and then all we need now is that point on the tangent line so that we can write the equation in point-slope form. So there's a couple of different ways that you could solve an equation of the tangent line problem. In this scenario, they only give us, they give us an x value. And so if I have an x value, well, how do you find your y value? Basically, you just plug in your x value, right? And so that's what we're doing in this next step. So since the line I'm looking at is tangent to f of x equals x squared at x equals 2, I know the x coordinate for the point on the line. And by plugging that x coordinate in to the original equation, I have my y coordinate. So therefore, I have found the coordinates x comma y for the point of the tangent line. And so now I have the point, and I have the slope, and now I can write my equation. And before I go down all the way, I'm going to actually write it out here. So y minus y1 equals m x, minus x1. And I guess in this scenario, I should have been writing that this is x1 and this is y1. It's just a point, right? It's not your formula itself. So this is x1, y1. And then up here I wrote it as well, so x1, y1. So if I'm going to actually fill in my information for this, I can do y minus y1, which is 4, equals m, which was 4, and then x minus x1, which was 2. So I have officially done it. I've written the equation for my tangent line. So that's what we do here. You'll notice that in this process, right, they write the equation first and then they simplify it to a slope-intercept form. In FRQs, you would never have to simplify it. We could leave it here, right? So this would be for an FRQ, that's perfectly acceptable. For a multiple choice question, this would be much more obvious. Okay, so you would have to be able to simplify it in a multiple choice question, but for FRQs, go ahead and leave it just in its point slope form. And then they say to check the graph to see if your answer is reasonable. You're never going to have a graph basically to look at. So, and then it says it gives us a little summary for how to do equations of the tangent line. So I can go ahead and do another example of those, but I do want to talk about one other piece as well before we do that. So let's go through the steps though. Find the first derivative, find the x value of the indicated point to find the slope. So basically you need your derivative, then you plug in your x value to find your slope, and then you plug in your x value into your original function to find the y coordinate of the point. And sometimes I do this one first. So I'll do this step, it will be secret step 0. I usually like to find my point first, and then my derivative, and then my slope. And then we don't actually graph the results to see if they're reasonable. The last thing I do want to talk about, though, is something that it doesn't pop up super often in the AP test, but I want you to be aware of it. Sometimes the test will ask you for the equation of the normal line. And so basically what happens is this. I'm going to do some. Right, so here's your graph. Beautiful. Oh no. Here's your graph. Okay, and if I'm doing my, let's say I had my x squared graph still, right? So we got curve, yada yada. And then here's my tangent line at that point, right? So there's your tangent line. The other thing they could ask you about is the normal line, which is perpendicular to your tangent line. If you are in physics or you've taken physics at all, then the normal line is usually the normal force is what happens when an object, for example, like if my phone is sitting on the table, my gravity is working on my phone, but then the table is pushing the exact same force back up at my phone so that neither the table nor the phone move at all. And so basically, that's where we use normal lines for the most part. But in calculus, you just have to know that they're perpendicular to your tangent line. So if your equation of your tangent line, is y minus y1 equals mx minus x1, right? Where you have the point x comma y, and then m is really your derivative at that x value. Basically, the equation for your normal line, it is y minus y1, and then perpendicular lines have opposite reciprocal slopes, so -1 over m x minus x1. So you don't actually have to do any other work. Like we would still follow all the steps for the equation of your tangent line, but then you would just do the opposite reciprocal slope for your normal line and then get your answer that way as well. Okay, so I'll go ahead and I think I have you practicing some delta math questions first. With those problems, if you are stuck, please watch the video and I'll just go through and do some of them for you so you can have some more examples to work off of before you practice on your own. All right, thanks guys.